My name's Marianne Griffith and I'm the Interim Executive Director for the London Environmental Network. We've had the pleasure of partnering with Chippewas of the Thames First Nation, or Deshganzibing, for a clean energy in remote and rural communities project where we identified a target area for the community in reducing energy costs and researching renewable energy solutions in the residential sector. We decided, along with the Treaties Land and Environments Department that we work closely with at Chippewas of the Thames, to pilot a home on the Chippewas of the Thames First Nation to as near net zero as possible, and use that opportunity as a community capacity building experience where we're teaching some of the community members who are particularly keen about new technologies, including air source heat pumps, which will help the community lose their reliance on expensive propane that's also high in greenhouse gas emissions. Chippewas of the Thames had a community energy plan done in 2020 where they identified that 88% of the housing there is heated using propane. That's vastly larger than the 1% that's heated by propane throughout the rest of Canada, and only 2% of homes in Ontario are heated with propane, which is very expensive, it can be unreliable, and it is one of the higher pollutants. We wanted to show that we could take the home straight from propane to electricity and skip the natural gas step that we've done in the London community, for example. So when we first audited Wanda's home, she was using a relatively high efficiency propane burning furnace for heating. We have swapped that out for an electric air source heat pump. It's the Mitsubishi Zuba model, and it's for whole home heating and cooling. Got roughly a 300% efficiency rating and should save her significantly when we are able to run the numbers after a year of use.
My name is Nolan Stenson. I work with Donaldson Home Services. We are here today to remove the traditional burning of fossil fuels furnace and air conditioner and moving towards the air source heat pump, which runs solely on electricity and removes the need for fossil fuels. Traditional homes, they rely on natural gas to heat your home. This house, given its location, does not have the natural gas running underneath the home, so it relies on 2 tanks that hold propane. Propane is obscenely expensive in comparison to natural gas, so the need to move away from that is greater in this area. The air source heat pump obviously doesn't use any natural gas or propane at all. It relies solely on electricity, which will in long term save them a lot of money. So a common misconception with air source heat pumps is that you lose the luxury of having air conditioner. That is not true. It'll work just like it did before. The convenient thing about the Zuba made by Mitsubishi is everything can still attach to the existing ductwork. A traditional air source heat pump system will have a wall-mounted unit that hangs on the side of the room and provides you with both your heating and air conditioning, whereas the Zuba connects right into the ductwork again, so you don't lose any of the luxury of having your air conditioning while also saving money for your heating bill. So just like everything else in terms of heating, the air conditioning side is also much more efficient. The traditional air conditioner system that was here pre-existing was a 13 SEER. The SEER rating is the governing body that dictates the efficiency of the equipment. The higher the SEER number, the more efficient the unit is. So we have now gone from a 13 SEER and we're getting close to a 20 SEER. So it's going to be much more efficient, and it will be easier on the wallet when the electricity bill comes in. Another concern with an air source heat pump is how low the unit will operate at an efficient manner to provide heat for the home. The Zuba can operate up to 80% of its efficiency down to negative 35 degrees Celsius. We don't often experience that sub-zero temperature in southwestern Ontario. It happens very, very rarely, but the unit will provide sufficient amount of heat to keep them comfortable in negative temperatures. All right, so here we can see the system is installed and up and running. As you can plainly hear, it is much quieter than the traditional forced air system. And rather than having the furnace in the basement and your forced air system outside. This will do your heating and cooling all in one. This is the new indoor unit that connected directly to the existing ductwork that was here with the traditional forced air system. So this is your blower at the bottom, which moves the air through the home, the coil on the inside that will effectively heat and cool using the outdoor unit, and the electrical backup if it goes below -30, excluding wind chill outside if it's ever needed. Now with this new system in place, the client can experience not just comfort improvements with a full modulating system, but also precision humidity control, as well as lowered in cost to operate the system. Over here we have the ERV, which is your energy recovery ventilator. In the summertime, it is going to exchange air from the outside to introduce it to the inside, improving the indoor air quality. And in the wintertime, it's going to do the same thing, but at a little bit higher velocity, which will effectively remove some of the humidity. It is not standard in a home. They are becoming a little more popular, especially a new build, which it is now a code requirement to have one of those units, as when you increase the efficiency of your home, the humidity does not have a chance to escape, and that's why they are required. It's important for everybody to start at least considering this as an option to move forward to. As convenient as natural gas and burning fossil fuels is, we understand that there is a finite supply of it, so eventually we will run out. The sooner we can get ahead of the game and start jumping onto this technology, the better.
We are switching her from a propane burning domestic hot water heater over to an electric tank water heater. Attic insulation to R60 and have air sealed the home using a blower door. So we were able to identify where her leaks were in the attic and the basement and seal those using a new company called Net Zero Insulation. Luckily, Wanda was interested in replacing her siding as well. So we were actually able to do continuous insulation around the exterior of the home, which will really help us get as close to net zero as possible.
Yeah, hi, my name's Steve Sponseller. I'm one of the owner-operators of Net Zero Insulation, and we're here today at Wanda and John's house doing an attic insulation retrofit where we'll be removing the existing insulation and air sealing the attic floor, as well as adding some ventilation to the attic, and then topping them up to R60. The stuff that they have in the attic right now is fiberglass batt insulation, and I mean it's still used quite commonly today, but the main reason why we're removing it is, well, A, because there's quite a bit of air leakage that is underneath the insulation that without pulling out the insulation it would be next to impossible to air seal the attic. And B, there's been some critters and animals and bats and stuff that have been active in the attic, so the existing insulation has come to be a little bit saturated with feces and animal urine. And what's in your attic is, quite frankly, it's in the air in your house too. So we're going to get that stuff out of there so it can help with a little bit better air quality inside the house as well. So once the insulation is removed and we've vacuumed out all the areas, then we go in with, depending on what we're actually air sealing, there's different applications, but a lot of times we're using 1-part foam and sealing up all the different air leaks. Or one tool that we use to help identify the air leakage locations is blower door testing and infrared camera or thermal camera to help us pinpoint some of the locations. A lot of times when blower door tests are done for an energy audit or something like that, they depressurize the house and basically suck all the air out of the house, and then they're measuring the air infiltration. When we're looking for the air leakage locations in the attic, we'll actually reverse the fan and pressurize the house, and then with a thermal gun inside the attic, we're able to point the camera to certain areas, and depending on the day and the weather circumstances, a lot of times you'll be able to see where there's actual cold air from inside the house escaping into the attic. The insulation that we're using today is a blown-in loose fill fiberglass insulation. It's made here in Canada, and the reason why we use the blown-in insulation is you get a more even and consistent depth of insulation across the entire attic. It helps to eliminate thermal bridging, which is when you lay batts in between wood studs. A lot of times if you're just putting one layer of batts, you end up with what's called thermal bridging, and that's where you actually lose heat right through the wood trusses themselves. So by putting the blown-in stuff, it kind of gives a more uniform blanket of insulation across all the attic floor and all the other components that make up the roof. So the house, they'll be going from an R32 to an R60 in the attic, and basically what that's going to do is it's going to help keep the house warmer in the wintertime and cooler in the summertime. The way that insulation is designed to slow the transfer of heat. It doesn't stop heat transfer, it slows it down. So I mean, you're basically doubling the amount of insulation, so it's going to take longer for the hot air in the summertime that's collected inside that attic to get into the home, and in the wintertime it's going to keep the warm air inside the house longer. The big thing is when you combine the increased insulation with a more airtight house is when you'll really see start to see the savings and notice the improvements in comfort.
I'm Ron from Ron Linker Roofing, and I'm doing a insulating upgrade and new siding for the Stacy family. Essentially, the house was built in about the 70s with R12 insulation in the walls and no air infiltration barrier. So what we're putting on is a R9 isocyanurate insulating board with an air infiltration barrier. So once this is installed and taped, it becomes an air barrier and prevents the movement of air from the inside of the home to the outside. And what that's going to do is it's going to prevent drafts and increase the R value of the home, almost double. With getting upgraded heating equipment, they're not likely going to notice much with energy savings from the insulation itself, because the new furnace will be that much more energy efficient, but it'll be much more comfortable. Everything will feel warm rather than having a draft from around the windows or from the floor. What we happen to do here with this cantilever portion is typically during construction, everyone thinks it's the other person's job to insulate the framing that's essentially outside. So I removed everything and upgraded the insulation and prevented that cold air from entering the floor system of the home, thereby causing it to be much warmer and comfortable. I've seen it quite often where the siding gets changed, they add an insulating board, but the insulating board only goes up to the existing soffit, leaving 8 inches of the original home exposed or not as upgraded as the remainder of the wall. So what we've done here is we've taken the soffit down, removed the nailing board, are installing the insulation directly to the underside of the roof rafters.
We applied to Hydro One for a net metering solar project and were approved, so we have ordered a solar array to be installed on her roof, and that is roughly 7 kilowatts and should provide enough electricity to net out the building's energy usage once the project is complete.
My name's Curtis Visser and I work for German Solar Corporation. So we're at the Stacy's residence installing about 6.1 kilowatts of AC solar, and it's about 6.4 kilowatts DC solar. Each of the modules is 425 watts, and they'll be connected to microinverters. and each microinverter will service basically 2 modules and then converts to AC. The AC gets collected in the lines, and that goes to the main distribution panel on the house. So this system will be set up as a net metering contract. So basically the power that's generated will just rotate the meter backwards, and you'll gain credits towards your bill. And then if it's cloudy or it's nighttime, then your meter will spin forwards, and then you'll consume those credits. So it's just a power offset. Net metering PV system will complement the heat pump and reduce the reliance on any kind of fossil fuels used for heating the home. On this system, the microinverter system is a very simplified, streamlined system. The inverters don't have any buttons on them or any screens on them. All you do is plug the panel in and plug it into the power grid. So there's no maintenance on the inverters. There's very little you can do with them. As well, there's very little maintenance on the panels.
An important part of the project is capacity building in the community, and we decided with the Chippewas of the Thames team that a webinar series would be the most accessible way to share information at this point. So we've developed a retrofit webinar series and have identified 10 community members in Chippewas of the Thames who are going to attend all of the sessions and a home tour of the retrofit project once it's complete. And those are going to be our energy champions for the project, all of whom will be paid to participate and will receive an honorarium at the end of the project. After the project was done, we surveyed them, and of the participants, 100% felt that they learned important information that they could use on their own home or in their own community. A year after we flipped the solar panels on, we were able to track how well the retrofit did by comparing the post-retrofit data to the pre-retrofit data by using utility bills. We're very happy to say that the building reduced over 94% of its emissions. Switching to electricity has made the home less expensive as well, and has saved the homeowner over $2,225 a year to start and over $75,000 over the course of the equipment's lifespan. Over 25 years, the retrofits will result in reducing over 71 tons of emissions. By switching out the propane-reliant heater and appliances, we were able to cut 100% of the propane required to heat the house.
So as the energy coordinator for my community, our biggest goal is working towards net zero. So right now we do have the Wanda Stacy's house that is net zero home. So it'd be nice to get everybody to that state. Did 40 Energuide audits within the nation to determine like what's the biggest need here. Our next step is to do the air quality testing so that our members know what it is that they're breathing in, because there's a lot of health issues with our elderly people and our children. So moving forward with that, we're trying to, identify what's in these homes and seek opportunities to fix them. We're looking at different ways of switching it up and, eliminating that propane, because it's very expensive for our people. They won't come out without no less than $500. And for the cost of living and stuff like that, some people don't have that, and it's hard to get that. So, and trying to gather data on the usage of propane, they don't have nothing for us. Here now, the work that we're doing, it's upgrading these homes so that they're comfortable. They're not breathing in these molds or anything like that. It's all about the health and safety of our people. Had the opportunity to bring in 2 youth interns. There are youth energy interns, and they've been with us since May. And since then, we've done solar training with Jazz Solar. We've attended conferences. They've came with us to do the Energuide audits to see how they were done, what it is that you need to do, and the EAPs. Building that capacity within our nation so that, because they're our future leaders. We need those youth to get involved more and carry these things out, because we're aging out too. For me, it's building knowledge and it's passing it on so that we get to where we want to be within not just ourselves, but within a nation. This is a tri-res area. I'd like to see Chippewa, Montana, and Knight on the same page when it comes to energy and the environment, so that everybody is living comfortably.
We hope to empower folks to live within their value system and start making changes to their homes and their way of living that reflects how they value the environment around them. We hope to continue to provide incentives and work with different funding streams to bring opportunities to the people who need it and want it.